Picture this: a single raindrop falling from a cloud hits the bare soil of your raised bed at around 20 miles per hour. It is not a gentle thing. That drop, for the split second it strikes the surface, delivers pressure comparable to a bicycle tire pressed onto a pinpoint of earth. Soil aggregates, those tiny crumbs that give good soil its structure, literally explode. Clay and silt particles scatter sideways into the air. A few of them fall back and begin settling into the gaps between the ruined aggregates, forming the first thin layer of what will become a hard, shiny crust. That is what happens in the first second of a rainstorm on bare soil. And most gardeners never see it. They see puddles, they see runoff, they see their plants looking stressed the next day and wonder why. What they do not see is the underground story. The biology, the chemistry, the physics, all unfolding in a choreographed sequence beneath the surface of their raised bed. It is happening right now, every time it rains, and it determines whether your plants thrive or struggle more than almost anything else you do as a gardener. So let me take you down there. I want to show you the first 72 hours after the first raindrop lands, because once you understand this, you will never look at rain on your garden the same way again. Let us go back to that first minute. On a bare soil-raised bed, raindrop impact shatters the surface aggregates. Within 30 seconds, fine clay particles have begun clogging the pores just below the surface. By a couple of minutes in, there is a thin, dense layer forming, less than 5 millimeters thick, but dense enough that it can cut infiltration by an order of magnitude or more. Soil scientists call this a structural seal. When it dries, it becomes a crust. The permeability of that crust can be several orders of magnitude lower than the soil beneath it. So all that water you see pooling on a bare garden bed, it is not because the soil below is saturated. It is because a paper-thin skin on top is refusing to let water in. If there is mulch on the bed, almost none of this is happening. The mulch absorbs the raindrop impact. The aggregates stay intact. The pore structure stays open. Water continues to move into the bed at something close to its initial rate. Field research shows mulch can reduce runoff by more than 80% in heavy rain. That is the difference between a bed that soaks up a storm and one that sheds it. Now follow a droplet that does make it in. Water entering the profile is pulled by two forces working together. Gravity pulls it down, and capillary action, which soil scientists call matrix potential, pulls it sideways into the smallest pores. In the early minutes of a rainstorm, capillary suction is the dominant force. Water spreads through the top few inches of soil, finding every crack, every gap, every thread of fungal hyphae to travel along. As pores fill with water, something else happens. AR is displaced. Air comes out of the top of the soil profile. You cannot see it, but if you put your ear close to freshly watered soil, you can sometimes hear it. A faint crackle as thousands of tiny air pockets collapse. The soil is, in a very real sense, breathing out. And here is where the first real problem starts. Water does not hold oxygen the way air does. The oxygen diffusion rate in water is roughly 10,000 times slower than in air. So when those soil pores fill up, oxygen in the root zone plummets. Within an hour of saturation, root metabolism begins shifting from normal aerobic respiration to anaerobic fermentation. The same thing yeast does when it makes alcohol. Your tomato roots start fermenting. That is survivable for a short time. Most vegetables can handle a few hours of this. But if the bed stays saturated for more than 24 to 48 hours, root damage becomes permanent. And it gets worse in warm weather, because warm soil demands more oxygen in the first place. This is why bed construction matters so much. A well-built raised bed about 10 to 12 inches tall, sitting on native ground, drains through both gravity and capillary continuity with the soil below. A bed sitting on concrete or a patio behaves completely differently. It acts like a giant container, and at the bottom of any container, a saturated layer forms that soil scientists call a perched water table. Water literally cannot fall out into empty air. It hangs on, held by surface tension, until the soil above is almost completely saturated. Which brings us to one of the most persistent pieces of bad advice in gardening. Put rocks in the bottom of your raised bed for drainage. Look, I know it seems logical. Big, chunky gravel. Water flows through it easily. Problem solved. But that is not how water moves in soil. Water stops when it hits a textural boundary. It piles up above the gravel layer until the soil column is saturated enough to overcome that barrier. Adding rocks to the bottom of most raised beds does not improve drainage. It reduces your growing volume and creates a problem that would not otherwise exist. If you want better drainage in a raised bed, the answer is better soil structure and better bed height, not a rock layer at the bottom. Now let me take you into the part of this story that almost nobody talks about. What the living things in your soil are doing while all this is happening. A single teaspoon of healthy raised bed soil, about 1 gram, holds up to 1 billion bacteria, several miles of fungal filaments, thousands of protozoa, tens of thousands of different species, more living things in a spoonful than there are people on Earth. And they have been sitting there, a lot of them dormant, waiting. Then the rain arrives. Back in the 1950s, a soil scientist named H.F. Birch was studying East African agricultural soils. He noticed something strange. When a dry soil was re-wetted, there was a sudden burst of microbial decomposition, a pulse of carbon dioxide, a flush of nitrogen becoming available. And then, as the soil stayed moist, the activity settled back down to normal levels. Dry the soil out, wet it again, and the pulse happened again. His papers in Plant and Soil and Nature from 1958 through 1964 laid the foundation for what we now call the Birch effect. Here is what is actually happening underground. When soil dries out, microbes do two things. Some of them go dormant. Others accumulate protective compounds inside their cells called osmolytes to keep from drying out entirely. Organic matter that was previously locked inside dry soil aggregates becomes physically trapped. Then water arrives. Dormant microbes rehydrate within minutes. The ones with osmolytes suddenly have to dump those compounds because the cells would burst otherwise. Those dumped compounds become instant microbial food. Aggregates break down from the wetting, releasing organic matter that was inaccessible a moment ago. The whole thing is a giant feeding frenzy happening on a microscopic scale. Bacterial populations can double in 15 to 30 minutes under these conditions. So, in the first hour after a significant rain, the living population of your raised bed is exploding. And that explosion creates a pulse of carbon dioxide coming out of the soil and, more importantly for the gardener, a pulse of mineralized nitrogen. This is where the Birch effect actually reaches your plants. The bacterial bloom by itself does not feed them. Plants cannot eat bacteria. What turns microbial biomass into plant food is predation. Protozoa, those single-celled hunters, multiply on the bacterial bloom. As they eat bacteria, they excrete ammonium. Nematodes do the same thing. Up to 80% of the nitrogen your plants take up comes from this predation cycle, not directly from soil organic matter. So the post-rain window, roughly 24 to 48 hours after a good soaking, is when your soil is most biologically alive. Nitrogen is flushing into plant-available forms. Protozoa are cycling nutrients. The soil is in what ecologists call a hot moment, a brief window of disproportionately intense activity. This is why experienced gardeners sometimes plant, transplant, or side dress with fertilizer a day or two after a rain. They have been riding this pulse their whole lives without knowing the biology. If the biology underground is new to you, hit subscribe. I cover the science behind what actually works in the garden every week, and what comes next might be the most satisfying correction to common garden advice you hear all year. While all that is happening, something else is going on that most of us grew up getting wrong. The earthworms. You have seen it 100 times. A heavy rain ends, and the sidewalks are covered in worms. The story we were told as kids was that they come up to avoid drowning. Their burrows flood, they cannot breathe, they surface to save themselves. That story is wrong. Earthworms breathe through their moist skin. Most species can survive submerged in water for days. Some can survive for weeks. They do not drown in a flooded burrow. So why do they come up? Scientific American and researchers at the University of Illinois Extension have been working on this. The current best explanation involves two things. First, carbon dioxide. Worms expel carbon dioxide through their skin, and in a flooded burrow, that carbon dioxide cannot diffuse out efficiently. It builds up, lowers the local pH, and drives the worms upward. Second, and this is the one most of the data supports, mating and dispersal. Wet weather is the only time many earthworm species can travel long distances across the soil surface without drying out. The adults you see on sidewalks after rain are almost always adults, not juveniles, which is exactly what you would expect from a mating migration. So the classic story was wrong. Earthworms surfacing during rain is not a panic escape from drowning. It is a choreographed part of the underground rain response. The bed is doing what it is designed to do. Meanwhile, underneath the surface, the mycorrhizal fungi network is adjusting. These are the microscopic fungal threads that colonize plant roots and extend far out into the soil, sometimes covering distances 30 or 40 times longer than the root system itself. They handle a brief rain well. Moisture is good for them. But if the bed stays saturated for more than a couple of days, they start to struggle because, like roots, fungal tissue needs oxygen. In a healthy aerated bed, those fungal networks do something remarkable during and after rain. Their hyphae physically bind soil aggregates together, and they exude a protein called glomalin that acts like a biological glue. They are literally holding your soil structure against the impact of rain. Without them, each storm does a little more damage than it heals. By 24 to 48 hours after the rain, a well-drained, mulched, biologically alive raised bed has reached what soil scientists call field capacity. That is the moisture level the soil can hold against gravity. Beneath the surface, the bacterial bloom is peaking. Protozoa are cycling nitrogen. Roots, now that oxygen has returned, are taking up the nutrient pulse. Mycorrhizal networks are rebuilding. Earthworms are moving freely through the loosened soil, mixing and aggregating. By 48 to 72 hours, the system is returning to baseline. Respiration rates drop. The microbial population declines as substrate is consumed. The weeds you are about to see germinating are feeding on the same pulse your tomatoes are feeding on. The soil surface has dried enough to work. The bed is ready for you. Which brings us to the practical part. You cannot control the rain, but you can control almost everything about how your raised bed responds to it. 3 things matter more than anything else. First, cover your soil. 2 to 4 inches of straw, shredded leaves, or arborist wood chips. This single change reduces runoff, prevents the surface seal, protects aggregate structure, keeps soil temperature stable, and feeds the biology underneath. It is the highest leverage thing a gardener can do. Second, do not water immediately after a significant rain. Even if the top looks dry, the root zone is at or above field capacity, and oxygen is at or near its minimum. Adding irrigation right then extends the low oxygen window and hurts your plants. Wait until the top inch of soil is dry before watering again. Third, use the post-rain window. The 24 to 48 hours after a good rain is your soil's most biologically active period. Transplant seedlings. Side dress with organic fertilizer. Weed. The soil is workable, the nitrogen pulse is flowing, and the biology will reward the work you do now more than it will reward the same work in a week. And if you are building a new bed, put it on native ground when possible. Make it 10 to 12 inches tall for a balance between drainage and water retention. Fill it with a mix that is roughly 40% topsoil or mineral fraction. 40% compost, and 20% coarse aeration like sand or pumice. Skip the rocks at the bottom. Here is what I want you to take away from all of this. Your raised bed is not just a container full of dirt. It is a living system, and every rainstorm is a test of how well you have set that system up to respond. The cascade I just walked you through, the impact, the seal, the oxygen collapse, the microbial bloom, the nutrient pulse, the worm migration, the fungal binding, the return to baseline, all of it is happening in your garden right now, every time the sky opens up. You cannot stop it, but you can decide whether your soil is ready for it. Cover your soil. Time your work to the pulse. Trust the biology. And next time it rains, you will know exactly what is going on down there.